Let us now learn how to write the structural formula of an alkene. The first member is ethene. We know that it is a 2-carbon alkene. So how can we show the carbon skeleton? 2 carbon atoms joined together by a double bond. As in the case of alkenes, here also we need to satisfy the valency of carbon by adding the required number of hydrogen atoms. So here it is a double bond between 2 carbon atoms. So 2 valencies are satisfied for both the carbon atoms. So we need to add 2 more hydrogen atoms to both the carbon atoms. Thus we get the structural formula as CH2 double bond CH2. Now consider propene. We know that it is a 3-carbon alkene and a double bond is also present. You can show the double bond between any 2 carbon atoms. Thus we get the carbon skeleton as C double bond C single bond C. And after that, satisfy the valencies of each carbon atom by adding the required number of hydrogen atoms. So we get the structural formula as CH2 double bond CH single bond CH3. Now consider butene. It is a 4-carbon alkene. We have to show double bond between any 2 carbon atoms. So there are 2 ways of showing the carbon skeleton. Either you can show the double bond between the first and the second carbon, or you can show the double bond between the second and the third carbon atom. Now once you get the carbon skeleton, you add the required number of hydrogen atoms to satisfy the valency of each of the carbon atom. So if it is the first structure, then we get the structural formula as CH2 double bond CH single bond CH2 single bond CH3. And if we have shown the carbon skeleton the other way, then we get the structural formula as CH3 single bond CH double bond CH single bond CH3. Let us now study how to write the structural formula of an alkyne. The first member is ethyne and we know that it is a 2-carbon alkyne. Being an alkyne, there should be a triple bond between the 2 carbon atoms. So we get the carbon skeleton as C triple bond C. Then satisfy the valency of each carbon atom by adding the required number of hydrogen atoms. We know that the valency of each carbon atom is 4. So we get the structural formula as CH triple bond CH. Now consider propyne. It is a 3-carbon alkyne. So join any 2 carbon atoms by a triple bond and 3 carbon atoms should be present. So we get the carbon skeleton as C triple bond C single bond C. And after that, add the required number of hydrogen atoms so that the valency of each carbon atom is satisfied. So we get the structural formula of propyne as CH triple bond C single bond CH3. Now consider butane. It is a 4-carbon alkyne and there should be a triple bond between any 2 carbon atoms. So here in the case of butane, there are 2 ways of showing the triple bond between the 2 carbon atoms. So we can get the carbon skeleton in 2 different ways. And after that, add the required number of hydrogen atoms to get the structural formula. So the structural formula of butane, we can get it as CH triple bond C single bond CH2 single bond CH3, or it can be CH3 single bond C triple bond C single bond CH3. Let us now study how to draw the electron dot structure of ethane and ethene. Ethane is a 2-carbon alkane. So you can show 2 carbon atoms with 4 valence electrons around each carbon atom. And then arrange the hydrogen atoms in such a way that each carbon has 3 hydrogen atoms around it. Each hydrogen atom has 1 electron. Then you can show that a pair of electron is shared between carbon and hydrogen. Then you can show that a pair of electron is shared between the 2 carbon atoms. So this is how we draw the electron dot structure of ethane. Now consider ethene. It is a 2-carbon alkene. So we have to show 2 carbon atoms. But here in this case, when you show the valence electrons with each carbon atom, out of the 4, 2 of the electrons should be facing the other carbon atom. Here in this case also we need to arrange the hydrogen atoms in such a way that each carbon has 2 hydrogen atoms around it. We know that each hydrogen atom has 1 electron. Then after that, show the sharing of electrons between carbon and hydrogen and between the 2 carbon atoms. So from the figure it is clear that a pair of electrons is shared between carbon and hydrogen, whereas between the two carbon atoms, 4 electrons or 2 pairs of electrons are shared between the two carbon atoms. That is, a double bond is formed between the two carbon atoms, which is true in the case of ethene. Consider ethyne. It is a 2-carbon alkyne. So you can show 2 carbon atoms, but here in this case, out of the 4 valence electrons present with each carbon atom, 3 should be facing the other carbon atom. And you can show 1 hydrogen atom present with or near to each carbon atom. A pair of electrons is shared between carbon and hydrogen, whereas 3 pairs of electrons are shared between the 2 carbon atoms. So that is how we get the electron dot structure of ethyne. Now consider carbon tetrachloride. You can show carbon at the center and arrange the 4 electrons in such a way that each of the electrons should be facing the chlorine atom, each of the chlorine atom. And each chlorine atom has 7 valence electrons. A pair of electrons is shared between carbon and each chlorine atom. So that is how we get a single bond between carbon and each chlorine atom. So this is how you can draw the electron dot structure.